Hey everybody, it's Miss Sullivan talking triangles and Pythagoras' theorem. So before we begin, let's just remember some stuff we already know about triangles. If I've got a triangle that's got three equal sides and it has three equal angles, I've got an equilateral triangle. Terrific. Obviously in an equilateral triangle, all of the angles are going to be 60 degrees because all the angles in a triangle add up to 180. So 60 times 3 is 180. So if all my angles are going to be even, in an equilateral triangle, every angle is going to need to be 60 degrees. Now let's talk isosceles. Isosceles are triangles where two sides are of equal length and two angles, the angles that are opposite the equal sides. So this one's opposite this side, this one's opposite this side, they're going to be the same. So we've got two equal sides and two equal angles, and we get an isosceles. A scalene triangle has all three sides are different lengths and all three angles are different sizes. So really quickly, let's use the fact that we know all angles in a triangle add up to 180 degrees to find some missing angles. Let's start here. We've got 180 minus 62 minus 50. So 180 minus 62 minus 50. I'm cheating. 180 minus 62 minus 50 equals 68. 68 degrees. That's our missing angle. Let's find our missing angle on up here. Let's find x up here. Now if I look here, I've got two lengths that are the same size. Oh, I'm looking at an isosceles triangle. So if the opposite angle here is 68, then the opposite angle here is also going to be 68 degrees. So again, in order to find x, it's going to equal 180 minus, let's just go with 68 times 2 so we can remember BIDMAS for a tick. So multiplication comes before addition and subtraction. 68 times 2 is 136. 180 minus 136. So 180 minus my answer. Note that I just use a little answer button down here. 180 minus my last answer equals 44 degrees. X equals 44 degrees. Terrific. And finally, let's have a little look at this one. I know this is a right angle triangle because it's got the little square. Don't assume that something is a right angle unless it's got the little square. So I know that this one is 90 degrees. So let's have a little look. If I want to find x up here, I know that x is going to equal 180 minus 90 minus 40. So x is going to equal 180 minus 90 minus 40. X is going to equal 50 degrees. X equals 50 degrees. Now we worked that out just by remembering rules associated with triangles. And it's led us to our last set of triangles. Sorry about that, a bit jumpy. Right angle triangles. They're triangles where one angle is 90 degrees. So I know it's 90 because it's got the little square. And it's also important to remember with right angle triangles that the side opposite the 90-degree angle is called the hypotenuse. So this leads us to one of the coolest mathematical, well really it's a mathematical discovery ever, which is Pythagoras' theorem from around the 6th century before the Common Era. So that's kind of cool. It's really important to remember Pythagoras didn't invent Pythagoras' theorem. He didn't invent right angle triangles. He noticed, well, he made an observation that occurred particularly when people started building stuff, that where you get a right angle triangle, you get this one long side. And working out that one long side, the hypotenuse, the side that is opposite the 90-degree angle, is really, really useful. So to work it out, and it doesn't matter what size the triangle is, you can find the hypotenuse by adding the square of one side and the square of the other. So the square of the hypotenuse, let's just call it C, the square of the hypotenuse equals the sum of the square of the other two sides. So let's just say that A equals 4, let's call it meters. A equals 4 meters, and B is going to equal 7 meters. A squared is going to be, so A is 4 squared plus B squared, which is 7 squared. So we get 16 plus 49, and 16 plus 49 is 65. So C squared equals 65. C must equal, so I did 16 plus 49 equals 65. Now I'm going to do the square root, that button there, the square root of my answer. I'm just going to hit this button down here, the square root of my answer, which equals 8.06222, or 2257748. Just a little reminder, we're going to round this to 2 decimal places, which is usually what you do, but make sure you read questions carefully. So we're going to round this one to 2 decimal places. So I look at the 3rd decimal place, it's below 5, so the 2nd decimal place stays the same. So therefore, C equals 8.06, and here's our little sign, meters. Don't forget your units. Excellent. So when you're calculating the hypotenuse, Pythagoras' theorem says the square of the hypotenuse equals the sum of the square of the other two sides. And that's really helpful to know when you're trying to find the sides of triangles. So if we've got a triangle that looks like this, well, right angle triangles, we can find the missing side. Let's have a look at this first one. Opposite the 90-degree triangle, opposite the 90-degree right angle, I've got my hypotenuse, which is already identified. So I've got 12 centimeters, and really importantly here, the other side that I've been given is 30 millimeters. So it's going to be really important to keep these guys in the same units. So I know that 30 millimeters equals 3 centimeters, and now I'm working in the same units. So 3 squared, we'll call this one x. Cool, I'm sorry, I'm just moving it around so you can see it. So now I know that 3 squared plus x squared equals 12 squared. So 9 plus x squared equals 144. Now I'm going to solve this just like a linear equation, and I'm going to do a bit of reshuffling. I'll get rid of positive 9 off this side by taking 9 off this side. So x squared equals 144 minus 9, which is 135. X is going to equal, I just did my little sign over there, so I got 135 so that I could do this again. The square root, that button there, of my answer, and it equals 11.61895004. Again, I'm going to round this to 2 decimal places, so I look at the 3rd decimal place. This time it's above 5, so 1 is rounded up to 2. So it becomes 11.62. Remember, I'm working in centimeters. Cool. Let's have a look at this one. So this time, opposite my right angle is my hypotenuse. This one's in meters, this one's in centimeters. To make the numbers as small as possible, I'm going to divide this one by 100 and turn it into meters. So I know that 2.5 meters squared plus, because I'm trying to find this missing side here, plus x squared is going to equal 8 squared. So I know that's 2.5 times 2.5 times 2.5 equals 6.25. I've got 6.25 plus, get the calculator out of the way, x squared equals 64. Again, using my linear equation solving skills, I'm going to get rid of positive 6.25 by, I took 6.25 from this side, I'll take 6.25 from this side, and I end up with 64 minus 6.25, and I get 57.75. 57.75, and if that's x squared, to find x, I need to go with the square root of my answer. Again, I'm just pushing my little answer button, and it equals 7.59934277. This time when I round this to 2 decimal places, the whole number's going to change. So I'm rounding that up, it becomes 7.60. 7.60, and what units was I working in? 2.5 meters, 8 meters, 7.6 meters. When we talk about rounding to decimal places, please don't forget to check the question. Don't forget to read what the question is asking you to do, and never forget units. I've got to be working in the same units. I did it there, and I did it here, centimeters and millimeters. Terrific. So that's what we remember about triangles and Pythagoras' theorem. Triangles, all the angles are going to add up to 180 degrees. That could be really helpful to help me find missing angles. And Pythagoras' theorem, obviously remembering that the square of the hypotenuse equals the square of the hypotenuse equals the square of the sum of the other two sides, is seriously helpful for finding missing lengths.